Okay, well, final session for today. And I hope you're still energetic and your brain is open for what is coming next. First announcement for the speakers, which is funny and important. Whenever someone is pressing the button for the elevator, the screen will go black. So it's not your fault if you don't see anything on the screen. It's the fault of someone who is taking the elevator. I have been told that the blackness will only be for 2 seconds and then everything will go back to normal. So don't panic. Just stay and talk as much as you can to to avoid anything which goes wrong. Yeah. Welcome back after this really nice finger food. I enjoyed it very much, I must say. Slovenko, I really love your hometown. This city is amazing. It has a brilliant architecture. The food is great. The people are very warm-hearted, and wherever you come, everybody is smiling, which is such a nice and good atmosphere. And even this location is amazing. I like it. It's a brilliant organization, and yeah, congratulations to you and of course to the team. My name is Matthias Martus. For those who don't know me, I am the CEO of Infratest Prüftechnik in Germany. I'm based in Stuttgart, and I have 3 colleagues today with me. Ersun, you already saw yesterday with his amazing answer question event. And we have, please stand up, we have Infratest Adria with Romana and Drago. My lovely colleagues from Zagreb, and they take care of this challenging market here in this area, and I'm really glad I have them because they always do things also with a great smile. First of all, I want to apologize to all my participants because in this session maybe I'm not a perfect moderator. I'm used to talk, but there are a couple of things I'm not as good as Juan. He did it perfectly yesterday, introducing all the people. So I apologize when I miss something. It's due to my, slipping mind I have sometimes. I want to start with a short word about innovation in the APA. The APA voted for me the perfect president last year. And because when it comes to innovation, Ralf and his company are a perfect model of an innovation-driven company and successful innovation-driven company. And it's a very, clear structure in this company which helps to innovate and brings them forward, and they are successfully what we are doing. And Ralf, thank you for being Ralf. And you must imagine it is a big difference to talk about innovation and to do innovation with your own pocket, which a company owner definitely has to do. Yeah, innovation. I thought a lot about this, and I want to start with something which is maybe in my DNA for many, many years. Maybe some of you knows it. To boldly go where no one gone before. Some Trekkies may know that this the introduction of Starship Enterprise, which when I was 5 or 6 years old, every Saturday evening flew into space. Flying into space, what does it mean? You fly in the unknown, and you constantly have to leave your comfort zone. You don't know what's coming. You don't know the aliens. You don't know the surprises you have. And but you have to question your comfort zone every day. And this is, for me, the real success and the key to innovation. Question yourself every day, is what I'm doing in my common, behavior, is it the right thing? Or do I have to change something because the world around us is changing dramatically? The speakers in this session, now I come to the introduction, They are an example for that. They go through this process. They are all very experienced, but they are here because they always constantly question, are we on the right path? Do we have to change something? And they did change something, and they started to make innovation lively. Fly in the unknown. The first guys I have to introduce they are from Mapri ASPHALT, from Ljubljana, Iztok and Primož. They're sitting here. Primož is the owner and founder of the company. Iztok is the guy who has to talk, which is good. You made something better than me because I'm the owner of the company. I have to talk, so I would also like to sit and relax. But anyway, I found a lot of good roads around Ljubljana when we arrived 2 days ago from Zagreb. So I think you are partly responsible for that. And you told me that you're in the middle of the process of a digital transformation. And you stated that for you it's very important that every database you have, you need the information top down. Not only the engineers, but the complete workforce has to know where this digital transformation is going. And so that all swim, as we say, in the same boat. And you also mentioned it is getting more and more complicated, which we of course know, but it is always a thing we have to talk about. All these experienced guys we know from, rollers and from pavers, they will go into pension, they are in pension, and the database, which is now starts to exist, is a very, very important thing to transfer this experience to future work people and to the future stuff, so we can have no lose in quality and time. That's all. Iztok, you want to come and talk?
Session.
Go.
Okay. Thank you for the introduction. Just a bit. Okay. Sir. Okay. It's fine. Okay. Introduction was already made. My name is Iztok Poljanšek. I'm from the company Mapri proasfalt, and today I will show our solution to the problem of the HR problem to get people to work for us. Okay. Sorry. There are three main problems. First, we don't get all the data that we need to know how the rollers are operating, which we find to be one of the bigger problems. Because if we don't know what's happening behind us, we don't know what the end product will look like. The data should be in real time, so we can manage or try to tell the people that are really working at the site what they have to change with their behavior. And at last, we also need the data for future improvements at our work sites. Our part of the solution is to get the people that are operating. They don't have enough experience, and they have a lot of other things to do except to operate the roller, or the worker doesn't have the time to look at the back of the paver what else is happening, because most of his time is going to the paver and the logistics around the mixture. Also, the experienced guys that are managing the projects, they have more than one project, and they don't know actually at the time how the project is progressing and what they should change if they want to get a better product. And at last, the the manager doesn't get any feedback of the product or doesn't have the data to know what they have to change or to get a better outcome for their projects. If you look from the other side to the solution, to the problem, we come back to the same problem. The workforce is fluctuating more than ever before because most of, not most, there are a lack of workforce and the fluctuation is bigger than it was previous. So the roller operators don't have the experience to know how to handle difficult operations or difficult situations on the site. Our solution to that one is to get all the data just in time, to put it in a cloud and to show the operator as well as the foreman and the manager or worksite director to what is going on and what they should change, if they should change anything. It goes to, you can look at on a remote control as well as on a stationary application. And also afterwards you can use the information or the data to analyze what went wrong. The data that we capture is similar than it was previously shown yesterday. So we look at the location, the movement of the roller, so we know how many times it passed by, and get the temperature every time that they work on the site, and also at last we get how much pressure or how much the engine was working, so we know how efficient our rollers are operating on the site. The web application is the roller is showing the operator the temperature in which they should operate, and we decide which gap to use. So we don't need so much skilled operators to know what to do, because it's shown them by display when and where to use their roller. Because if they go outside of the temperature gap of the surface, the display shows them that they shouldn't work there anymore. Also, can the foreman be at the paver without going back to the rollers to see if they operate in the right temperature window or not? And if we look at the management or at the director of the project, he has on the display in which temperature they work, how much the operator of the roller is working, where it is at the moment, and what is already done. So if they make enough number of, well, I forgot the name of that, passes, it went green, and if it's green, they don't need to work there anymore. So we have a more efficient way to look at the usage of the rollers. So we know how many times they went by and if it's enough or not. The temperature gap is for us very important. Otherwise, we have to have more skilled operators, that they know what will happen if it's too hot, if it's too cold, and how long they have to be on site. Also with that, we don't get in the position that the operators will stop too soon when the workday is done and stop working before the asphalt is cold enough that they shouldn't work anymore. All the data is also captured and can be analyzed afterwards, so we can see what's going on. If we take it, the sensors are on the roller itself. It shows also the operator in which temperature gap they should work. Also has the foreman, the location, and on the cloud is everything stored. So even if there's no connection, it will go afterwards to store in the cloud and can be analyzed for improvements afterwards. For the managing side, it's also possible to see the locations where are the rollers, and in a quick look how they are used, or even if they were necessary to use to bring there. So we can lower the cost of logistics for the rollers. And I think that's it. It was a little bit quicker than I thought it would be, but if anyone has a question, I'll answer at the end, I think. Sorry.
So the good thing is the screen didn't went black. So obviously nobody is using the elevator right now. Great. Bart, where are you? Here, come. I asked him what to say about him. I said, tell them I'm the funny guy from Belgium. Now I found out he's working for a Dutch company, which is more or less funny. 18 years of experience in the asphalt pigment or pigment industry. He still looks young, not too much pigmented. And yeah, that is a huge background. 18 years is something, and we want to hear about this more. Tell us, please.
Yes. Thank you, Matthias, for the introduction. Today I want to give a small presentation about colored asphalt, and more in detail a cycling lane in colored asphalt. And yesterday the kickoff of Mr. Henningman was, I remember 2 words, a cycling lane and safety. There are 3 words. Yes. Anyway, I work for Ventraco. Ventraco is a member of the International Colored Asphalt Foundation, the ICAF. Other members are suppliers of colored stones, suppliers of bitumen or clear binders. Another member is doing the finishing touch, like printing asphalt or polishing mastic asphalt. In Zurich, I think they do a lot of polishing mastic asphalt, then you get a marble look or a terrazzo effect. What we do is we give education, that's a big word. So we give support and technical advice to contractors or to asphalt plants by saying, if you use pigments, you can reduce your filler. If you use pelletized pigments, you can reduce your bitumen, make that everything is clean, the trucks, the mixer, and so on. And what we also do is we give inspiration and possibilities with colored asphalt to municipalities, architects, study bureaus. And the architects, sometimes we have to say also the limitations because they have fantasy enough.
Sure.
Why do we promote cycling? First of all, on every exhibition and symposium I was for the last years, it's all about green deals, CO2 reduction, carbon footprint, and so on. But I think it's obvious if you have less cars and more bikers in the city centers, yeah, then you have a CO2 reduction. Same for the local air quality. You have less smog or less NOx. And what we also see, if you have less cars in the city center, then you have more space. And on the space, you can create green areas or green playgrounds. And then you have, then they give oxygen. So cycling leads also to a healthier life. What does it mean? If you're moving, if you're on a bike, so you move to improve your body. Cycling increases also happiness. So when you're cycling, you can free up and clear up your mind, and you're not stressed in a traffic jam, or you're not stressed giving a presentation to the ZAS. But it saves also time. So if you have a distance of 5 kilometers or less, then it's even faster with a bicycle. And yesterday, when we were at the DARS, I was thinking, you see the big cross, what was it? Austria, Croatia, Hungary, Italy, and then you have the red cycle ring around Ljubljana, and it becomes redder and redder, maybe purple in some time. And I was thinking, why don't you put big parking spaces for cars, and there you can rent a bike, and in a bicycle lane you can enter the city center. Maybe you're thinking that I'm Einstein, but some cities did already before, so it's not that innovative. It's just an idea. Okay, cycling leads to safer cities. Less cars, less accidents, less car accidents. What we also have to do is to avoid contact with a cyclist and a car. And also, if you make a speed limit in the city centers, then you have less heavy injuries. So how can the city create a nice infrastructure to support the cycling? First of all, you can make separate bike lanes. What are separate bike lanes? Because now maybe you're thinking, but we have no space in the city center because there's no space. You have a two-direction street and two walk paths. But you can also, if you have less cars, you can make one direction street, and then you can make a cycling lane next to it. Then you have space enough. You can put some flowers also in between. The speed limit is important, so you have to go down with the speed limit to 30 kilometers an hour anyway. You have cycling streets. Cycling streets is a street where the bicycle has priority. So a car cannot pass a cyclist. We see them a lot in surroundings of schools, in villages. So it's very safe for the children. Then you have also cycling highways. And I've heard from my new friend Stefan that they are also doing it in Germany. And what is a cycling highways? It is a very long bicycle lane with as less as possible obstacles. And if there is a crossing or is there a roundabout, they make sometimes tunnels or they make a bridge over it. And we have a nice one from Antwerp to Brussels. That's in Belgium. So safety is the key, but that was already Mr. Henningman was saying. We need to have a fast and safe traveling. Cyclists must be visible, of course, and priority on the intersections. And we need to avoid also the contact between cyclists and other road users, but also pedestrians. And then a bike lane network must be extensive and interconnected. Last summer, I was with my family in Norway, and my daughter, she went cycling, and there was a nice cycling lane, of course, in red asphalt. And she started cycling, and out of the village, it suddenly stopped. And or she could turn back, or she could risk her life on the motorway without signs for a cyclist. So it must be bike paths or cycle lanes must be clearly recognizable, and we do it with colored asphalt. So why the reasons for colored asphalt is the biker, the people, he needs to be invited. So he needs to be sure this is my space, this is my property, and I do what I want. But also, if you have colored asphalt, the car driver, he knows also and is unconsciously, when I go right, I turn into a street, I have to be aware because I'm crossing another color of asphalt. And yeah, like asphalt, it is quickly open to traffic, of course, because it's asphalt. A wide range of colors are possible. It's a durable paving. It's asphalt. It has a high comfort for all users because it's asphalt. And also economical because some customers I see or people or governments or municipalities they say, oh, it's price, price, price. But what is the price of a human being? But that's another topic, I think. So the investment, you can put just a paint. That's the cheapest, but you see it in front of the hotel. There is a painted bicycle lane if you have good eyes. You have also 2-component coating, but that's really expensive. You can do it also with bricks, you see here. But the bricks are losing up, they're coming out. You see also the green between the bricks, so it has a lot of maintenance. So in fact, the best option is colored asphalt.
Yeah.
I think now maybe starts a movie. This gives some pictures, examples from projects. Most of them are in the Netherlands because it's our home base and it's very common in the Netherlands. Oh, voila. Light colored asphalt. What we recently see the last years, there's a lot of demanding of light colored asphalt. Last year there was a lot of projects in Paris, and it has a positive effect on the urban heat island effect. What does it mean? In summertime, it gives a reduction of 20% of the temperature. This does not mean 20 degrees Celsius, but 20%, which is also okay. It's also energy saving. In Luxembourg, they do every tunnel in white asphalt. What is white asphalt? Is clear binder, titanium dioxide as a pigment, and white stones from Germany, the Eiffel keys. And what they also saw, it was not only for the safety, because you're not driving in a black hole, but after 7 years, they gain already back the extra cost of the light-colored asphalt. So I thought the Luxembourgs, they were friendly people because they want to do it for the safety, security, but they're just making money. Because everybody knows asphalt in a tunnel has always the same climate, no frost, no rain. You have a speed limit. So it has a lifespan of, 15, 20 years or longer. Pigments. I can give 3 presentations about pigments, but I'm not going to do it. The most common pigments are metal oxides. So we have iron oxide, so the German flag, it's also the Belgian flag. Titanium dioxide, chrome oxide, and some, I mentioned already, some architects, they want to have special colors like organic pigments, but that's something else. Ventraco is a manufacturer of pelletized pigments. Pelletized pigments is a predispersed pigment by extruders based on a thermoplastic carrier. So it is pellet form, so it's absolutely dust-free. It has a higher color strength because powders are agglomerating in your asphalt mix, and pellets, they have already enjoyed the energy, so they're dispersing much better. They have also a positive LCA against powder. They give extra stability because the thermoplastic carrier is a part of it is EVA. And it's easy to dose and easy applicable. It's also much better for the health of the workers. There was a very long cycling lane in Romania with a huge, and there has to go 2 or 3 persons to the hospital because they had too much red in the lungs from the powers. So to make already the conclusion, my boss, Jeroen Venema, he said a quote, "A price is balance between pigment, the type of bitumen, filler, and aggregate is the key for achieving the best and longest lasting result." So pigment, yeah, of course, only one address. It's ASPHALT from Interchem. That is our partner here in Slovenia. The type of bitumen, you have clear binder. You can make a lot of colors with clear binder. And with black bitumen, yeah, only a few. The filler is important. If you have, if you use pigments, you can reduce your filler first of all. But the filler, if you take a recuperation filler of your own, it's difficult to achieve a light colored asphalt. And aggregates, maybe the aggregates are the most important of the colored asphalt, because after a while, 1 year, 6 months, 2 years, whatever, depending on the weather and the friction, but after a while, the color stones will determine the color. Testing is also important for your own, to see the behavior of the colors, the new color stones and the pigments in your mix, but also show it to the end customer what he can get, because sometimes the expectations are something else than reality. Raw materials, I said already, production. Please be aware, because asphalt plants, they're making 99% black asphalt and only 1% colored. So please make your workers aware that everything is clean, that they mix a little bit longer. On the application side itself, make that the rollers are no rust, make they are clean, everything is clean.
Yep, let's shut the yes.
Did I say something wrong?
Yeah, you have 10 minutes, which is now.
Okay, this is the last. Is it already? Oh, time flies. Okay, so there is an increase in demand for cycling infrastructure everywhere, and it is supported and promoted by the European Union everywhere, Ireland, Paris, but I'm not going to sum up all Europe, but also here around the corner in Zagreb, we are busy now with a green asphalt lane, supported, in fact, paid by all of us, because it's the European Union. Voilà, that was it. But first, to end, I want to thank Tadeja for for inviting me to this conference, and also to the nice city of Ljubljana. Thank you.
So cycling is healthy. I cycle a lot, and when after cycling I talk to my back and to everything else which is down under there, which they have a different opinion. Jorge. Yeah, we just talked. You are postgrad from the university in Valencia, and your topic is a very interesting one. I think you are creating a digital twin to improve efficiency during HMA production. And I would be happy if you show us your twin right now. Thank you.
Thank you, Matthias, for the introduction. In fact, this presentation is almost a continuation of the previous one, because once you have a monitoring system, developing a digital twin comes as a logical outcome. So the digital twin we are developing, we have called it Twin Asphalt, and it's based in our monitoring system. The presentation is structured in 3 parts. In the first one, I will give a brief overview of the digital twin architecture, which includes a simulation model on which I will focus a bit more. And in the parts 2 and 3, I will talk about how we are validating this simulation model for decision-making purposes. The digital twin we are designing follows a classical structure. In the bottom layer, we have the monitoring system I've been talking about in the previous presentation, which is responsible for taking information about the current state of reality. And based on that information, the simulation model is set up and forecasts what will happen through the rest of the journey. So our simulation model is designed for telling us information about what will be the result at the end of the journey. And with this simulation, what we want to do is to see how we can improve our production process. And this will be addressed in the last layer of the digital twin, in which by means of optimization algorithms and visual analytics, we will enable our planners and plant operators to improve the efficiency of the process. So this is our ultimate goal, to improve the efficiency of the process by providing our personnel with an assistant. The twin model, which is inside our digital twin, has to cover the full range, the full scope of the production process, which includes not only what is happening in the production site, which we have depicted in blue, but also we need to know something about the demand and also about the supply chain. So this is very broad scope, and it's quite difficult to build a logical model of all this without losing control. To keep control, we have resorted to the agent-based simulation approach, which enables to create agents representing the real stakeholders into the process, which are like autonomous subsystems. And then we can articulate interactions between them. So this way we can keep the whole scope in control. And within each of these agents, we can describe the processes they carry out. So, for example, this picture corresponds to the main agent, which describes the processes, the transformation process of raw materials into asphalt. And let's see if the video works. Yeah, so it describes minutely the different parts of the process, the feeding process, the heating, where the aggregates are heated and the dust is extracted and sent to its silo. Then the aggregates will move through the elevator to the tower, where they will be screened, and this enables classifying them according to their gradation and to their size, and store them into the hot hoppers, where they will be ready for the next stage, which is the dosing stage, in which we put some of each material into the mixer, mix them, and then they are ready to be transported to the construction site. So we have developed also a transportation submodel and also a very simplified model of the life cycle, the pavement life cycle, to simulate or to be able to carry out life cycle analysis. This as to the process engineering stage, but even within some of these processes, we need to get more into detail. For example, to model the phenomenon, physical phenomenon that happens in the dryer, which is complex. So we couldn't address this problem through conventional discrete event simulation, nor establish a knowledge-based model. So we resorted to data-based models in which we take the information, historic information provided by the monitoring system, and build a series of models. So, for example, this is used to forecast what the temperature will be based on a set of variables. One of these models forecasts the temperature of the exit of a dryer based on the Barnes power, the production rate, the humidity of the wrap, the humidity also of the sand, the ambient temperature, and the proportion of sand. So these are relevant variables influencing this process, and we model them through data analysis, mainly with quadratic regression models. And this was all about the architecture of our simulator. Next stage is to test its validity for decision-making purposes. So what we wanted is to check out whether changing what we thought would be the decisions we may take will lead to improvement or to worsen the performance of the process. So for that, we evaluated different strategies, which we code through a number of decision variables, and built scenarios in which we also had some parameters. Parameters don't change between scenarios, the variables do. And by means of our virtual model, we evaluated these strategies in terms of CO2 equivalent and the time taken for completing the demands. The decisions were coded in terms of the number of trucks available for the transportation, the order in which job sites are attended, the Barnes power, the proportion of sand we use to produce of each receipt, and the production rate. So we combined them in a way following a full factorial design, and we also added some more levels to have a more complete view in some of the variables. And then with the results, we built, once again, regression models to explore the effect of each variable on performance. And we saw that increasing the number of tracks up to a point had a positive effect, as did lowering the proportion of sand, which is also quite easy to expect. And also the order, what was interesting is that the order in which we address the job sites also have a slight impact, as obviously has the Barnes power and the production rate from certain points on. And as to the impact on the delivery time, we found that increasing the number of tracks and the production rate obviously leads to reduced time, but it is not linear. So there are points from which on they may be interesting or not to going on. And what was interesting is that we by scheduling the works in a certain way, it does not affect the total time for attending the demand. So we infer from that by properly scheduling our works, we can improve the efficiency in terms of CO2 production without penalizing the time. And from these findings, we can also extract some, draw some conclusions, variable per variable, which I have synthesized in the conclusions, which in some means that the model is capable of offering insights for decision making in terms of the effect of the decision variables in the performance of the production process, that the number of tracks are important in reducing CO2 asphalt. So in our analysis, we didn't take into account the CO2 produced by the number of tracks, so we need more research in in this line, we have to improve a bit our model to show a more complete results. It is possible to improve the efficiency of the process without, in terms of CO2, without losing performance in time in time for delivery. We can also find a compromise solution. We have to look for compromise solution between production rates, in the production rate between CO2 reduction and the time taken for completing. And also, since mixes with a higher rate, higher proportion of sand are always more generating more CO2, this should be allocated in times where the ambient temperature is greater to reduce their impact to reduce the CO2 emissions. And currently, we are developing the decision-making model to build optimized solutions in an automated way and provide with them to our planners and plant operators. And we are also adding to our virtual model, to our simulator, new features based on the retrofitting or upgrading projects and a new plant we are building together with IFASH at Madrid. And so these new features will also be incorporated into our models to to have a wider range of decisions. And this was all from me. Now, if you have any question, I would be glad to answer. Thank you very much.
Questions at the end. Okay.
Thank you, Jorge. Yeah, data is the base of everything, which we had now in almost every presentation in this section. And the next presenter, Rok, where are you? Here, he's coming. I think he's also a data-driven guy. Rok from ZAK, I like that. He was responsible, he was head of the laboratory for building physics, and as I understood, you are now on leave for making your doctor, right? Yes, where?
At the University of Most.
Where is this?
Slovenia.
In Slovenia, okay, very nice. Acoustic and noise control are your key aspects, and I will turn off the micro now so that you can be as loud as possible. And stage is yours, please.
Enjoy this.
Yes, thank you for that nice presentation. And like the presenter already said, my expertise is noise. And I'd like to talk to you a little bit about how this affects the asphalt and road surfaces in general. Okay, let me just see. Okay, some background. It started, like a lot of things, actually with European Union mandating that we have to use these common noise assessment methods for European Union, called NOSOS EU. And this is mandated to be used for strategic noise mapping. Basically, we need to measure noise pretty much everywhere on all the roads in Europe. And two things that you need to know to understand this presentation is basically two things. It's important, the asphalt is very important in the noise levels next to the road. Everything about 50 kilometers basically depends on the tire road interaction. And to measure this, we need to know how noisy certain asphalt surfaces are. Here on the left side, you can see how we used to measure noise next to the road. Basically, we just put a microphone there and we measure how noisy this street is. But of course, to do this on a large scale, you need to simplify things. You need to do them on a larger scale as well. And how do we do that? Basically, we need to get the data. We need to measure somewhat faster than what I showed before, because that is localized noise measurement. We need to measure everywhere. And to do that, basically we mount our microphones next to the tire and we drive around. That's it. We drive around and we collect the data. And in this way, we can measure a lot of the roads very fast. Basically, we're going 100 kilometers per hour, literally. Now, as we do this, we measure the noise levels, and we have to. This is not really important, but these are the equipment used to do this. And here on the right side, you can see are the road surfaces that are important, at least for Slovenia, because pretty much every country in the EU will have to do this for their own asphalt mixtures. But for us, these are the most important ones, and they cover pretty much all the roads, at least on highways. Okay? So now that we measured our noise everywhere, basically on all of the highways in Slovenia, what do we do with this? This is a lot of data. Basically, we measure 20,000 samples per second on 2 microphones, driving over all the roads. We have to set up a database. We need to put this data somewhere so we can do some nice analysis on it. What we did is we used GeoPackage, which is an open source database based on SQLite. It's quite fast. It's spatially indexed. Basically, that means it's fast and allows for different geometries, which will be a bit more important later on, as I will talk about it. It doesn't really have any limit with size. If you are used to something like shape files or something for your database, those are limited to something like 2 gigabytes. And it doesn't have some other limits like the length of the column data or column text or something like that. And very importantly, because we're doing analysis on this, it has to have good automation. Basically, it has to be compatible with stuff like Python or whatever program you use for doing statistical analysis. So what we used was basically QGIS, which is a program I highly recommend for displaying. And we use Python and all the Python libraries for statistical analysis. And like we said, we were successful. We measured all these roads in the highway system. And we presented to our regulators a suggestion of how these Knossos coefficients should look like. Basically, we said, this asphalt is this noisy, this asphalt is this noisy, and so on and so on and so on, for pretty much 96% of the asphalts in Slovenia. I have to be careful for the types of asphalts that cover the roads in Slovenia. Okay, so we were successful, great. But then we said, what else can we do with this database? What else can we do with this data? And I want to do further 2 examples of what we did. One thing that we could also include in our database was expansion joint noise. Like some other guys from ZAC already presented, we do a lot of inspecting of bridges and viaducts and stuff like that. And what we can do with our database is basically we look at a very small segment of our noise measurements and say this segment, this noise, basically correlates to this bridge joint. Yeah. And as you can see here, these dots, these purple dots, are all the expansion joints that we measured. And we measured this in 1 day. And this is the noise levels. Basically, as you drive over the expansion joint, it does tup. You can see this peak, and this is the spectral data of this expansion joint. And we can do a list of expansion joints. There are different types of expansion joints, but we can do a list of these joints and say, okay, we measure these joints, and this joint here, I don't know which one, let's say this one, is quite loud compared to other joints of that type. And we can say to our colleagues at ZAC, okay, this joint seems quite noisy. Maybe you should go and check it out. Maybe you should do a manual inspection. Those things take a lot of time. You have to drive that. You have to stop. Sometimes you have to stop traffic. So it's a lot of work. If we can do this, if we can lighten the load, then I think it's quite useful. And another example that I have to share with you is life cycle assessment or life cycle analysis. Basically, once we have this database of road surfaces in Slovenia, we can do life cycle analysis and say, let's say we exchange our most popular asphalt, SMA 11, with the same asphalt, but we add some crumb rubber to it. This is quite usual. And one of my colleagues did this analysis. And basically, if you do it on all the highways in Slovenia, which is something like 900 kilometers of it, then you can save about 1,800 tons of equivalent of CO2, which if you calculate it to the coupon value, it's actually not a lot. But the point is we can do this kind of analysis from our database. So what we want to do further on. Okay. Now, one of the things that we try to do is we're trying to expand this database to include different aspects. Like I said, we did it for noise. So for noise levels on the asphalt surfaces. We included the bridge joints, the expansion joints. We have to keep it customizable, so we can add different things to this database, so we can use it on different aspects. And we want it to be easy to share and present. So basically, if we want to show it to somebody, we can do it quite easily. And we really hope it will be used in regular monitoring data. So we will continue to do some measurements on it. We will add to it, and we can do analysis as time goes by. We can go, okay, this asphalt is aging this fast, and this asphalt this expansion joint is a problem, and so on and so on. And what this is doing basically is testing the claims. This is one of the claims that was by Renault in Internoise 2024. Basically, what they said there is that road surfaces, and especially the noise levels of the road surface, is very good correlation with CO2 emissions. Now, is this true? I don't know. I can't really say. But using these databases as basis, and like our colleagues showed us before with fuel emission and stuff like that, you can plug these things together and you can test these claims. You can say, okay, this is true or this is not true. And this can be really useful to everybody who does road management or any regulatory body that has to get some new laws or some new legislation in. We can be the expert opinion behind it. We can provide this data and we can provide some analysis to help them do this. So yes, that's it for me. Thank you for your attention, and please, if there are any questions.
You have to come later. Oh. Again. Yeah, I hope you have a lot of questions to these four guys later when we all sit there in a very cozy atmosphere and are open for any suggestion and questions you may have. So we have the last one coming now. Zvonko? Zvonko, where are you? No? You switched?
Yeah.
What did you switch?
It's just that he couldn't come, so I...
You replace him. That is good. Then I have to say nothing because I have no idea who you are. That makes it so much easier for me. Thank you for that. You talk about the same topic?
Yeah.
Great. Go.
Yes. Okay, my apologies again for this. Zvonko is my boss, so I have to apologize him. He couldn't come, so I did it instead. We did it. We are working about these things together, so it shouldn't be so hard for me. But
Here we are. Nobody knows.
yeah, this is where I wanted to come to because I wanted to talk about our team. It's quite a lot of teamwork. I am Brane Nastran, as you probably heard before. I am the head of Traffic Information Center. The Traffic Information Center is the part of the Traffic Safety and Traffic Department in our motorway company. And you've been, I heard yesterday, in our center outside Ljubljana. This is where our offices are, our operational people that work 24/7. And they are responsible for the whole achievements that we can make, because for us it's very important that we are connected with them. I will, then we came like before in the workshop session, we came finally to communication, to how we are doing this for drivers as we understand it, and for our point of view, especially for our Traffic Information Center, we are dealing with drivers every day. So we sense their attitude, and we are always in some kind of in trouble when we want to work on the road, because people on the road, they have an attitude that they are already again there. It's not necessary. We are always an obstacle, so we have to find some way through this, that our necessity that we work on the roads, that we keep it in good condition, keep it safe, and of course our drivers that are not very understandable all the time. So the very common attitude of them is that we are just doing something, like rolling, like Dionysus, this Greek philosopher that was living in the barrel, and he was walking around with his oil lamp, and people were asking, "What are you doing in the bright day with an oil lamp?" He said, "I'm looking for an honest person." And he was when he was living in Corinth, there was a threat from the Alexander the Great, or was his father Philip, that he would invade the city, and everybody were frantic, running around, preparing, doing something. And Dionysus was also coming out of his barrel, and he was rolling his barrel up and down the square. And people were asking, "What are you doing?" He said, "Well, everybody's doing something. I thought I should do too, because otherwise they will think I'm lazy and I don't care." So this is just an illustration how sometimes the opinion of the people is of our work, what are we doing on the roads, because we just have to, because everybody's doing it. But it's not so. And we want to persuade them that we are serious, that we know what our goal is. And we have, our focus is that to present, and it's hard to present to the people something. I can present you very briefly. What are we doing? We have some quite good expertise, people that are professionals, they are planning, and it's not like just like we say, okay, today we don't have anything better to do, let's go on the road and do something. So we are preparing it, it's planning, it's working, and the first thing is that you have to have a good diagnosis. Andrei, that is here, could tell a lot about it. it's a quite important work. And these are some examples what equipment and what applications we use in our motorway company to have a good diagnosis what's going on with the motorways. And when we get this, then we need good planning. And with good planning, in our side, when we want to communicate it to the drivers, it's very important that we are connected with, that we know the people that are planning their works, what are they planning and what are their plans and what are they doing. So we have a common applications. We connect our departments. This is one example of this common application when maintaining workers put all the data in one system, and then everybody that needs to do something about it or just needs to know it can find it here in this system. So we have the same experience, the same look at the system. So it's much easier to understand each other and to. Then the next step is also the traffic analysis, because when we go on the road, practically never in Slovenian motorways there is no good time to go to work on the motorway, because the traffic is increasing and it's so much traffic that every time we cause major problem, not just small problems, and we have to plan it carefully. So our traffic experts prepare all the time are preparing analyses about traffic flow, about the density of traffic, the characteristics of the traffic, how many trucks will be there, how many different type of vehicles, and when is the best time or the least bad time to go to work on the road. So when we come together and say, okay, this is what has to be done because this is urgent. Our analysis told us that this is we had to be repaired very quickly. So we find some good time when is the best time for that section to go to work, and then it's our job to manage traffic at that time and also to inform the drivers and to communicate it to the public. So we can try to change the attitude that we are just there rolling barrel. I'd already spoken this before today about our systems, that we use everything that is there out there. We are very keen to include ourselves into the development of digital communication tools and all the tools that drivers are using and all the data that are gathered out there, so we can use this for good information for the drivers in the car. And of course, also outside the car, you can see this up there. We use also, as I was talking today already, the driving simulator. It helps us quite a lot to see how the drivers would react to different kind of distractions in the car. And this is it. And I am quite confident that we are doing quite a good job, but it's still like Sisyphus, we drag this stone up the hill and it comes down. But it's okay. I always tell people that are complaining, look to our drivers, they are never satisfied. But I say, if they are complaining that we are working out there, that's good. We will be in trouble when they start to complain that we are not working, because there will be a bad shape on the roads, and it will be a really good, a big problem. That's it for my side.
Data, 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 data. I have an interesting data collected the last 60 minutes. We had 2 people using the elevator and 63 minutes. So it's also data. So I would love to have people on stage for the questionings. So you remember we started with collecting data during pavement with Iztok. Then we had the digital twin with Jorge. We had the bicycle lane with Bart. Where is Rok? Rok is sitting already, so we had the noise with Rok. And finally, we had the monitoring of the pavement or the street conditions with him. So, what questions do you have? You look fresh.
Start. Iztok, what do you think? Will you use this system for your company, also for all rollers in the future?
Hello? Okay. We already used it last year on the Northern Highway. We were testing it on 5 rollers because we needed more operators than we had, or more skilled operators than we had at the moment. So when it will be finished, we will equip all our rollers with it.
See.
Also a question for you. How do you determine the minimum required amount of roller passes and the temperature window? Is it based on research? Is it based on experience?
It's mostly based on experience because previously we always had a technician behind the rollers to say when they have to roll and they shouldn't. But nowadays it's too expensive to have another one that always checks when to roll and when to stop. So we use the old data that we already have to tell the operators when they should work, with which roller they should work, and how long. So they have a scale when to use it and when don't to have. They don't need to have to use it.
Okay. Can I have another question? A question then to Rok. You are doing this analysis on network level, the noise measurements. And I guess then it's also important that you have reliable information about the type of asphalt. Where do you get the data? And is it a coupled database?
Yes, thank you. That's a good question. Basically, we get it directly from a highway operator. Now, it's true that it's a database made from other databases, and it can be challenging to incorporate it. But once you have it set up as all databases, then it gets quite easy to use after that. So yes, the source is important, and what's more important and what's even harder to be sure of is that this database is recent. Yep. So we don't get data from like 5 years ago or something like that. So yeah, this is an important question. And hopefully if we do this often enough, we will get recent data as well. Basically, if you use this system, then the data will be recent as well.
More questions?
Thanks,
Alex?
I have one, but also to Iztok. When you are in the middle of this transformation and you have to have all the people involved working with the same in the same topic and be in the same boat, and I also have to manage a company, and when you do something new, they also this idiot now he brings something new. It's so difficult to convince the people and go to the base. How do you do this?
It's impossible. Hello, it's impossible.
Okay.
Because no one wants to change stuff that they already know. The people that have the experience, they don't want to share. Even if they don't want to share it, or they are not able to share it. So that's why we have to implement that one. So we have the knowledge and we have to give it to those that don't have it. Because those that have the knowledge, they don't use it and they don't want to use it. The ones that didn't have the knowledge, they are eager to know it, but they don't want to use it because they are scared of the changes. So we have to almost enforce it to use it. Otherwise, it's impossible that they will accept it.
I do think that's a common problem with all these new data coming in a huge speed. And when you just see, these were 5 fantastic and amazing presentations, but you see at the end that a huge wave of data is coming, and it's one thing to collect it, and it's another thing to use it in a proper and smart way. And but if you don't have everybody in the same boat, it could be definitely a problem. I'm, let's say, maybe a little bit more suspicious. I belong to an older generation. Younger people, they live with their digital twin, which they have always in their pocket, and maybe easier for them, but still it's a gap and it's a complicated task, I think. Yeah.
The only way is get those people in the boat if it's more comfortable. It's easier. They are all able to order pizzas and shoes in the internet. So why shouldn't they work with those systems? It has to be comfortable. This is the only way everything. This is why I think.
Even if it's comfortable, most of them don't want the changes. Because most of the technology is more simple than it was previous, but still they don't want to use it because they know what they're using now and are scared of every change. Because if we know more, we have more data, and they're scared that we can use it against them. Even if it's easier for them, because they don't know that we can't use all the data against them because it's not personalized like they think it is.
Yeah, I have also. Ersun. Does it work? No.
It's working.
Ersun, you have a loud voice, you just talk.
Okay, let's do it that way.
It's working.
It worked? Okay. I have a non-digital question to Bart. You said that you have in your pellets that there is EVA in it. And what is the effect of this EVA to the binder properties? And what is if the customer puts in too much of this pellets? Aren't you afraid that it becomes too stiff or?
Where?
Yes.
Hello. Ersun, that is a very good question. Because some years ago, where the bitumen became worse and worse, are there bitumen supplies here? Okay. So, in the past we had just a straight run, and everybody knows plus minus what was in. And then you had with a pellet. At that time, it was 20% of EVA. So the thermoplastic carrier was 100%, or the 20% was EVA. But you had no problems at all when you stay around -4-5%. But now these days, so everybody knows that we have no construction bitumen anyway, but we are helping the world because we have a green bitumen, because they do sulfur in it, they do ashes in it, they cracking it again, so the asphaltenes are going up, and the meltenes, the light friction is going down. And now you have the point, the EVA needs also the light friction like the meltenes. So we had problems in the past. We say to the bitumen supplier, you're going to change the bitumen, but they wouldn't listen. So we changed our pellet. So we reduced our content of EVA, and we put some extra meltenes in it. Does it cause problems? Not anymore. So from 2016-17, we changed the formula. And when you're not exaggerating, but even in a black binder, when you go up to 4%, you have now these days, I say not the bitumen in 5 years or tomorrow, but now these days, the problem is solved, what you mentioned. And at the other side, it gives more stability, like I said. So you know what an EVA does maybe better than me, I think. So, but we changed indeed and it was necessary.
Okay, thank you.
Yes, maybe I wanted to add something to the previous comments regarding the use of roller assistance systems. There was also yesterday a few remarks about fear and fear of change. Maybe to give a positive turn to it, in our company, we can see that especially with the working crews themselves, they are actually quite enthusiastic to use it. And it's maybe even the level above it that are, let's say, slowing down the process rather than people using it themselves, because they see where it helps them. So I think that is actually maybe shouldn't be too scared for the further implementation.
That was a statement.
It was business.
Yeah. Okay.
That is definitely to make sure that we end up on a high note.
Okay. More questions? No. Okay, I'm not sure what my role is now. But I want. I always dream of something. I want to do it right now because Captain Kirk was doing it always at the end of one session. He said, "Set course on innovation, engage."
Thank you very much. I think we had great moderators in these 2 days, but I think the best was where you are. Thank you. Thank you, Matthias, again. I will do a very short end of this conference. It will not take 15 minutes, only a few minutes. It was really a great pleasure for me and for our association, ZAS, with my team, all the members, to host this third ISA International ASPHALT 4.0 conference in Ljubljana. And in these 2 days, we talk a lot about data. And perhaps at the beginning, a few data from my side. We have 109 physically attendant of the conference and 20 registered on streaming. That means together 130. There were participants from 13 countries. We had together 34 speakers, and I'm very proud that 1/3 or 12 are from Slovenia, because this is the first conference from ZAS in these 28 years that we organized in English language, and I'm quite surprised that we can got 12 participants as speakers from my country. Of course, we are also very lucky as the organizers that we had so many sponsors, together 16, 7 major sponsors and 9 sponsors. We will prepare conclusions of the conference because it's necessary to have a paper document. We will try to do it very, very short. I will ask all the 5 moderators and especially Juan Jose and Ralph Port and Brexo Gomez that they help me, that these conclusions will be very short, that we can spread it, that we can go to other conferences and talk about this. As it was explained, we had 2 weeks ago a webinar with 1,400 people who listen in this webinar, and I think 100 people here, it's almost nothing. The most important is to give the message wider, that more people hear this, what we are talking about, because I think we are talking on quite very important topics. It's, of course, difficult to put things in a short time together, but I would say that there are 3 topics that on my view are the most important. First is the digitalization, the second is the big amount of data, and the third is the artificial intelligence. I think these 3 pillars are nowadays not only that we are talking about it will come, it is now in our life every day, and it is 100% in our businesses. And we have to deal with them every day. If we start in the asphalt industry, we use these technologies in preparing project with digital twins, then with the production, with preparing of recipes, with transport, with organization of the complete work at the end, with laying, compaction, and last, the quality control. All things we do today on these on these 3 pillars that I tried to explain. And we heard in these 2 days that perhaps the philosophy that we are as industry on one side, and our administration is on the other side, is not the right one. Because the administration who pays the contractors and the industry, we are together in one boat. The second part are the users. The second, our clients are the users of the infrastructure. And we should to change the philosophy and to put together our clients, the administration. It's something very difficult to be the administration. The changings in these positions are very fast. It's difficult they have problems to get additional knowledges and so on. And it's necessary for us to understand them. So it's necessary also to put them, to help them and work together. I think that this is a very important message also from this conference. And good of this is also that very often we are also the users on the other side, and we do it also for ourselves, of course. So at the end, I would like to thank the Spanish delegation who is here, Juan José Poti, the EAPA delegation with the president, Ralph Port. I would like to thank all the organizers who prepared this conference together in my team. I would like to thank outside, at the end of the hall, the guys who prepared the streaming. I got many information that it was excellent, but only 20 people there, but it was excellent. We had this nice platform to contact and so on. And we had a discussion today when and where should be the 4th conference. I cannot say that we have an end decision. There are different decisions to move to another country. There is idea to move to a big country and so on. But at last thing was that perhaps, because we had 2 conferences in Spain, in Madrid, we will go again in Madrid, but the idea was perhaps that the 4th conference will be next year together with the 20th colloquium on asphalt pavement and bitumen in Bled, in Slovenia. That means that we have also 2 conferences in 2 years in Slovenia, that we then move perhaps to Germany for the 5th conference, and the 6th conference would be then again in Madrid. This is now the idea that we discuss, and I think everyone was satisfied with this, and I think that we are prepared, and also we have the power to do it together with colloquium next year. So we will decide it, but this is the idea. I would like to put the sponsors on the screen if we have, because these are most important. And with this nice picture that Robert will put on the screen, I would like to finish this conference, wish you excellent trip at home, and hope to see you again next year, perhaps, as I said, in Bled. Thank you very much, and bye-bye.